I am Sr.G. Vignesh, working as an assistant professor in KPRIET Institute of Engineering and Technology. So today we are going to see the basics of magnet software. So this is the software. So in this software, by using this software, we can use different types of design analysis like electrical motor designs like induction motor, DC motor, BLDC motor, and axle flux motor. So like that, there are different types of motors can be designed, and you can see the what is the flux flowing across your motors between stator and rotor. You can visually see the total flux generation. So likewise, if you are designing an switch gear, if you are designing an capacitor or inductor, you can see the magnetic flux flows in the capacitor or inductor or in an even in the transformers. You are opening a software, so you have a three basic steps, so which you need to do before starting the design process. Okay, so first step is you have to set the units. First you have to select tools, and in that select tools, when you are selecting a tool, you have to select the set units. So when you are clicking the set units, you will have this page. Okay, so in this page you have to set the units. Okay, so for every design you will select the step 2 is selecting in millimeter. So this is the step 2. So in length you have to select the millimeters. So why we are selecting millimeters means all the AC or DC motors, if we are designing, we all represent the diameters or length in millimeters only. So we choose mm, that is millimeter, and time frame will be milliseconds, and frequency will be hertz, and then temperature in Celsius. This is the common step. So once you select all the parameters, you just click apply. So your third step is you have to select the keyboard input bar. So what is this need of a keyboard input bar is you have to, so if you are designing and if you are drawing a circle for designing your motor. Okay, so you need to give the input parameter. So if you are designing a circle, you have to give some values. So maybe the circle will be around 100 mm or 200 mm. For inputting the keyboard input values, so you have to select the keyboard input bar, which has to be enabled. So now when you opening a when you are seeing a software, so in your bottom you can see when you are not selecting this toolbar with the keyboard input bar is enabled. So this is how your software will show you. So once the step 3 is completed, you will get the keyboard input bar in the bottom of your screen. Okay, okay, so this is the three basic steps. We will directly go into the software and see. So this is the software. So as I earlier said, so first step you have to select the tool. In that you have to select the units. So in that you have to select millimeter. Okay. So after that, millisecond, time is milliseconds, frequency in hertz, and temperature in degree Celsius. After that you just apply the parameter. So after that, again you go for a tool. So when you are seeing the bottom of your screen, there will be no keyboard input bar. So when you are enabling the keyboard input bar, you will get the keyboard input bar. Okay, right click your mouse, go for a properties. In that you will have a background style. Here you can see background style. So in that select solid color. So when you are selecting a solid color, you can see the different colors. So when you are selecting a dark color, your screen will be in dark side. Okay, so this is how you can change your display screen. This is the design specification of our induction motor. For stator we are having 12 holes, and inner radius is 30, and outer radius is 50 mm, and thickness is 60 mm, and our gap between stator and rotor is 1 mm. For rotor design, we have number of pole is 4, and inner radius is 10, and outer radius is 29. So this is what we are going to design in our software. So now I am going to select the circle, and I am going to draw the circle. So for that, once I am selecting the circle, I am going to give the input parameter, initial input parameter as 0, 0. That is the center point. I am fixing the center point here, and when I move my cursor, when I move my mouse, you can see the circle. So I need to draw this circle for stator. So your stator inner radius is, you all know the stator inner radius, that is 30. So now we are going to draw for 30. And once you feed 0 comma 30 and give enter, you will get the circle for inner radius. So that is, inner radius is 30 and outer radius is 50. Now I'm going to draw a circle for 50. So for that I'm going to give, so again I have to give 0 comma 0 as a center point. So it is the midpoint where I'm going to draw the circle for 50. After giving 0 comma 0 and giving enter, you will get like this. When you are moving again, you just type your 0 comma 50 and give enter, you will get the circle. So now I am going to draw the design of stator. As we all know, number of poles in stator is 12. So I need to draw the 12 stator structure. So for designing the stator structure, number of pole is 12. So I have to draw this stator pole of 12. So for that I need to draw the line. So for drawing line, I am having formula called S is equal to R theta. In that, yes, we know that number of stator pole is 12. So I'm going to substitute that value as 12 and the radius is 50. So I will get the theta value. So once you calculate the value, so I'm getting 0.24. When you are calculating this, substituting a value, you will get 0.24, and I have to multiply the constant value 57.296 to get the final theta value. So my theta value is 13.75. So I have to draw the line for 13 point. For this 13.75, I have to draw the line. So I am going to select the line and I am going to give the initial value point from 0 comma 0, that is a origin point, and giving enter. So now I can see the, when you are moving the mouse, you can see the line. So I am going to convert the angle of xy direction to radius to theta value. Okay, and we know the radius is 50 and the angle for theta is 13.75. So I'm going to use the 13.75 and clicking enter. So I'll get the line. Okay. So I don't need to do the same process for all 12 status. I don't need to calculate the values of S and theta, and I don't need to calculate the line values. So I have a different option called mirror option. So I'm going to select this line. When you are selecting a draw, you will have a mirror edges option. So you have to give the value of 1 comma 0 and click on the apply transformation button and click OK. Now you can see the two lines. So if I need to select this line, I have to select construction line, and then you have to click on the lines. By clicking control, you can select multiple lines. Okay. So once you select the line, you can segment the edges. If you are not selecting any line, your segment edges, here you can see in the top, segment edges is not enabled. So once you select the line, your segment edges will be getting enabled. You can click on that and you can delete the excess of lines present when you are drawn. Okay, so now I have to draw 12 stator structures. So I'm having one stator structure. So how I am going to draw for remaining 11 stator structure is, we know 360 divided by total slots. So once you calculate the 360 divided by 12, you will get 30 degree. So I need to draw this two lines for 30 degree each. So for that I am going to use rotate option, which is available in the menu called draw. When you select the rotate edges, you have a rotate edges menu. In that you give the feed value of 30 and number of select the number of copies and select 11, because I am having 12, already one is having, so I am giving 11 and giving apply. Now you can see 12 stator slots. Okay, so I am going to select the stator slots. by pressing control button, you have to click all the status slots. So for selecting status slots, you have to give the select construction slice has to be selected, and you have to press the control button, and then you have to click on the surfaces. Now you can see here, make a component is getting enabled, similarly similar to of segment edges. Okay, select on the component. Here you can see the name. Okay, so for from the name, I'm going to fill this material with copper. Okay, so you can just type or you can scroll down, and then you can find the material. Here you can see the copper material. I'm going to select, and the distance is 60, and then I'm going to give apply button. So once I'm selecting the material, my material will be getting applied to the component. Okay, I can click on the examine button. I can examine the model. Okay, now, so I'm examined the model, so I need to fix the axis to xy direction. So here you have options called different view options. So side view, top view, front view, like that you can see the object. So I'm selecting xy direction, the front view option, and then you can select. So now I'm going to select the component for stampings. Once you select this component, you can similar method I'm going to apply for cold rolled steel is the material I'm going to give, and then I'm going to apply for the material. Okay, now I'm going to delete this all the circles. So for that, I'm going to select line construction slice line, and I'm going to give Control A, and I'm going to delete all the circles. Now you can examine the stator structure. Now I'm going to draw the rotor structure. So before that, you have drawn the stator, and each component will be visible in your object section. You can see the objects, and you can rename the objects by selecting right clicking the mouse. So you can select the component name, and you can give the rename the component. Okay, similarly you can do for all the components. Okay, now I have changed the stator component and rotor component. Now I am going to design the rotor. So for designing rotor, we know the inner radius and outer radius. Inner radius is 10 and outer radius is 29. So I am going to draw the circle. So I am going to change for xy direction. I am going to give enter 0, 0 and giving enter, and 0, 10, 0, 0 enter, and 0, 29, giving enter. Now you get the two lines. So if you need to hide the components, you can select the first component, and clicking shift and selecting last component, you can right click on your mouse, and you can disable your components, that is invisibility can be done. Now you can examine the you are going to design the rotor structure. So similarly for rotor structure, I'm going to design the rotor structure. So for that, S is equal to R theta formula I'm going to use. So we know the total number of rotor is 4 and the radius is 29. So when you're calculating, I'm getting 7.9. So now I'm going to select the line and I'm going to start the line from origin 0 comma 0, and I'm going to change the angle, and 29 is the angle, so I'm giving 30. So let me show you one thing. R is 30 and the radius is, we have calculated, it is 7.9. 7 point, I'm going to give 30 comma 7.9 and giving enter. Now I have drawn the circle. Okay, I'm going to, similarly I'm going to select the line and I am going to mirror the line. So mirror option will be available in the menu called draw, and I am going to select and giving 1 comma 0 and then going to apply. Now I have drawn the single stator. So now I know I need to delete the excess lines. So for that I am selecting two lines by clicking control and I am going to give the segment edges. So I have deleted the excess of line. Okay. So I have to check whether I have deleted all the lines. So there is an option called detect and bad edges. There is an option. So once I am searching that, it will show you the bad edges. So if you have not deleted any lines, so it can be visually seen from here. Again, you can see, so I have deleted the line. Again, you can check whether you have deleted the lines by same method. So it will show you if there is any excess of lines, it will show you the line. Once you delete, and you can again re-examine, and you can, if there is no error, it will show that there is no bad edges detected. Okay, so this is the process how I can identify whether I have deleted all the lines. Now I am going to draw the magnet surface for 4 magnet. I need a 4 magnet. So 360 divided by 4, I am getting 90 degree. So I am going to rotate this magnet for 90 degree. For that I am going to rotate the edges for 90 degree. Number of copies is 3. Okay, and once I give the apply button, so I will get the 4 slots. Okay, now I can select the object and I can create the material. Okay, so this is the rotor magnet material. This will be the rotor stamping. So for stamping, I am giving non-magnetic material. Okay, so this is the stamping material. This is the rotor conductive material. So for that I am selecting neodymium iron boron. So NdFeB is the neodymium iron boron. I am selecting and then giving apply button. Okay. Otherwise, you can go with the copper material for rotor. Maybe either you can go for an stator rotor with the copper material or permanent magnet material. Okay. So I have drawn. Now you can visually see the stator and rotor surface. So again, I am selecting the stator and giving the component. Now you can examine the model and you can see we have drawn the stator and rotor component. Okay, so this is how we are going to design the stator and rotor. So if we need to analyze or simulate the system, so we have another few steps. So initially, if you are designing a motor in the software, your motor will have a vacant surfaces. Here you can observe that there is a gap between stator and rotor. It will be the air gap. Okay, so even though if you are having air gap, you have to encircle the flux flow between stator and rotor in a constrained path. For that, we need to draw a air gap for a stator and rotor. Okay, so as we know, your stator inner structure circle is 30 degree and the rotor outer circle is 29. Okay, so in between that we are having 1 mm air gap. So now I'm going to draw the circle to cover the rotor surface alone. So that is 0 comma 0 and 0 comma 29.5. I'm selecting and giving a enter. Now I'm going to select this circle and I'm going to apply component as air. Air is the component I'm going to use. Okay. So once you apply the air, it will be getting applied for rotor. Similarly, I need to draw the, and now I am deleting the circle drawn for 29.5 and I am going to draw the new circle for covering whole motor surface. So for that, I am drawing circle for 60 degree. Okay. Now I have selected the circle. Now I am going to select this circle and I am going to apply air. Okay. Stator air is the component I am going to apply. Okay. Now you have applied the component for state. You have created a component and you have applied the air and objects. Okay. So now I need to rotate my rotor surface. So for rotating the rotor surface, I have to select all the components of rotor. I am going to create a motion component. For creating motion component, you have to select model and then click on make a motion component. Okay. So once you select, you will have a two system called load driven and velocity driven. Select a load driven, go for position. So your position of degree is start position to start is 0 and speed at degree per second is 20. Okay. So either position of starting can be 360 or degree or 0 degree, any positions you can start, but speed at starting point is startup is 20 degree per second. Okay. So once you select the parameters, you can give apply. Okay. Now you will have a motion component is getting created. Here you can see in the object page, your motion is getting created. So before simulating, you have to select some parameters has to be fixed. For that, you have to select solve and select the set transient option. In that, your starting point is 0 and stopping point is 360, and I am giving the step as 10. And your starting point, so you can unselect this portion, starting for transient power loss, and you can give apply. So once you are completed, you can solve this in 2D motion. Okay. So your simulation will get solved for 30 degree with the interval of 10, because we have given steps as 10 millisecond. So you will get the simulation output after running for 30 milliseconds. Now you can see the, so once simulation is completed, you will go for a you will get the result page. So in that you can analyze the speed. So if you need to select the speed and if you are selecting overlap curve, you can show the graph. Okay. So this is the speed of my motor. So I am getting nearly 1400 degrees per second. My motor is getting rotated. Similarly, if I need to know the position, I can select the position and I can see what is the position of angle of rotation. So up to 360 milliseconds. Nearly I'm getting one half sine wave I'm getting. Okay. So if you need to see multiple graphs in a single graph, you can select and you can see. Okay. So for energy between your stator and rotor, what is the maximum energy between magnetic and co-energy of what I am obtaining, I can select and give nearly 5 joules of co-energy is getting generated. Okay. For flux, for body forces, I can identify. So what is the body force between XY direction and Z direction? What is the flux flow between each surfaces and what is the maximum torque I am getting? So it is 0. Nearly 2.8 Newton meter of torque is getting generated maximum, and minimum value is around 0.1. It is the maximum, minimum and maximum value. Okay, so this is how we are going to simulate and see what is the design of my motor. So if I need to know, so I need to visualize what is the solid surface or flux flow. So you have an option called field option. So in that there you have different methods, so counter method, shaded method, air gap shaded, or arrow method. Okay, so this is to identify what is the flux function or flux flow. So once you select the flux function and counter, you can see the flux function of your flux flow between stator and rotor. So there is a gap, there is a blue lines, so this is due to air gaps. So you can select the air gap of my motion and air gap, and I can unvisualize, and you can see the flux surface. Okay, this is the rotor, this is the stator. So how the stator flux is getting interacted with your rotor surface, I can animate this surface, animate these values, and I can visually see the flux flow also. Okay, so I'm giving the shaded as none. Now you can see what is the flux flow. So if I'm having shaded as B update, you can give a maximum flux, average flux flowing. And if you are having arrow plot, you can plot the arrow plot for the same, and you can see what is the R flow. Okay, so if I am animating this, you can visually see what is the structure of flux flow between interaction between stator and rotor in an animated way. Okay, so now you can see the animation of a motor what you have designed. Thank you for watching the video.